You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem.
Good morning, good afternoon, and good evening, wherever you are. We are coming to you from Boston, Massachusetts. Today is August 7th, 2024. Hope everyone is doing well and staying safe. Can't believe we are in August already. Ryan and I started this podcast back in August of 2021. So this is like a 3-year milestone for us. Can't believe it's 3 years already. We are more than 75 episodes in. This has been a great ride for us. And as part of this podcast, we have had the opportunity and the privilege to talk to a bunch of awesome guests from the community, meet a lot of our listeners at industry events like KubeCon and Red Hat Summit. So I love that we are able to do this on an ongoing basis. Thank you so much for being a listener and sharing this podcast with your colleagues and friends. We really appreciate you listening to us, giving us the time of your day to just listen to us talk about a specific piece of technology or an open source project. We have definitely grown our audience over the years. And again, can't thank you enough. It's through word of mouth. It's just through people finding value in this podcast that we do and sharing it with the others that has helped us grow the audience over the years. 3 years is a long time to be doing something on a bi-weekly basis, that's for sure, but we're nowhere close to done, right? Like both Ryan and I are committed to doing this and continuing this journey. We both have had like job changes since we started this, but we have always made this podcast a priority, and that's not changing. I'm personally excited to continue this journey and keep evolving this podcast and continue talking about different technology stacks in and around the cloud native ecosystem. With that, let's talk about a few things happening in the Kubernetes ecosystem before we dive into the topic for today's episode. First one being Azure Container Storage, or ACS, is now generally available. So Microsoft announced this sometime last year, and it was available through its regular preview stages, so private preview, public preview, and now it's officially generally available. Azure Container Storage is a software-defined or cloud-native storage solution from Microsoft. They have derived it from OpenEBS. It's based on OpenEBS, which used to be a similar project in the open source ecosystem. With the general availability, they announced support for the underlying devices to be either Azure disks or ephemeral disks. And they also said that Azure Elastic SAN still remains in preview, but you can expect general availability for ACS with Azure Elastic SAN in a couple of months. Some of the features include storage pool expansion and resizing, replication across different nodes, customer managed encryption key support, ability to dynamically provision persistent volumes and take snapshots, and all the benefits that you get with like the CSI standard. All of that is included. We'll have a link in the show note that talks about the journey from inception to GA and the features that are available and how you can get started in the show notes. Next up, again, something from the Microsoft ecosystem today. GitHub, our famous like source control repository, is now adding support for something called GitHub models. So this means that you can now have access to large language models like Llama 3.1, GPT-4o, GPT-4o Mini, to small language models like 5.3, or models like other open source models like Mistral Large 2. You can access each of these models via a built-in playground inside GitHub that lets you test different prompts and model parameters for free right inside GitHub. And if you like what you're seeing inside this playground, they have also created an easy path to bring that models to your development environments in code spaces or Visual Studio Code. And once you are ready to go to production, the next evolution in the Microsoft ecosystem, as they mentioned, is using Azure AI, and that has all of these models available across all different Azure regions that they support. I'm just excited that there, in addition to Hugging Face, now there's a different alternative where models are being available to test out. And if you are in the Microsoft ecosystem, this is definitely good news for you. So those are the couple of things that I wanted to highlight as part of news, that things that are happening in the cloud native storage ecosystem. But let's move on to the topic for today and introduce our guests. So today we are going to talk about the Kubernetes AI Toolchain Operator open source project from Microsoft, or the KAITO project. We'll find out how the Microsoft folks say it. So to talk about the project, we have Sachi Desai, who's a product manager in Microsoft Azure, and Paul Yu, who's a senior cloud advocate focused on Kubernetes. He has been doing this for a while now. So, and fun fact, he's also a Kubernetes Bytes listener. So I'm excited to talk to him and have him share his thoughts around the KAITO project and what it is all about. So without further ado, let's bring Sachi and Paul on the podcast. Okay. Hey, Paul. Hey, Sachi. Welcome to Kubernetes Bytes podcast. I'm so excited to have you guys on the show to talk about KAITO. So why don't we start with like a quick introduction from the two of you and talk about what you guys do at Microsoft. Sachi, why don't we start with you?
Yeah, of course. Thanks for having me on the podcast. My name is Sachi. I'm a product manager in Azure Kubernetes Service. I've been on the team for about a year now, and I work within AI workloads and making them run more efficiently on AKS, as well as onboarding to GPU-related work streams and scheduler.
That's awesome. Paul, how about you?
Cool. Yeah. Thanks for having us on, Bhavin. My name is Paul Yu. I'm a cloud native developer advocate at Microsoft. I've been at Microsoft for a little over 5 years now, but I've done a ton of work outside of the company before then. Anything from ranging like from software engineering, solution architecture, and lately it's just been all Kubernetes for me. I think I've been playing with Kubernetes for the better part of maybe 4+ years now. So that's kind of like all I do.
That's awesome. Yeah. Yeah, Kubernetes is, I think, top of mind for almost everybody these days. And that's the topic for today. So, how Kubernetes fits in with AI, and that's what I want to ask you guys about.
Mm-hmm. Yeah.
Okay, so let's start there, right? Artificial intelligence, AI, ML workloads on Kubernetes. Why do you think they make such a good fit? And if we dive into it a bit more, where do you think it has more benefits, like on the model training side or on the inferencing and other architectures after the model has been trained side? And anybody can pick it up, yeah.
I can go into that a little bit. So when you think about AI workloads, it ranges from training, fine-tuning, inferencing, and you want to be able to run those workloads at scale. So as you're doing it large enterprises and factory kind of scenarios, you want to be able to run it reliably. You want to have portability there, version control, and all the necessary aspects that Kubernetes itself provides for your traditional microservices. And you can really apply it there for your large-scale AI workloads.
Gotcha. And is it more suited because of all the control plane capabilities? Because I've been talking to other folks from the community as well, right? There are some capabilities that are missing from Kubernetes, like batch processing and the ability to schedule jobs. How does Kubernetes handle all of that? Do you see the community making progress there?
Yeah, definitely. I feel like that's a great part of what I've seen with the cloud native community coming together, in that we have these KEPs, so these proposals that different working groups across the Kubernetes community can put together ideas for making Kubernetes more specialized for AI workloads. As you mentioned, you need specialized communication, for example, across nodes, so support for InfiniBand and those other specialized processes. So there are several AI-related working groups across the cloud native community that are making progress there. And we've seen that at KubeCon and many other events that have happened in the past few years.
Gotcha. And I think Microsoft has always been on the forefront of Kubernetes, right? It has been, I think, 18 months since we had Brendan Burns on the podcast to talk about AKS and all the things around AKS. So let's talk about the topic for today. What is KAITO? Or can you guys talk about, first start with what the full form is, what does it stand for? And then what is that new project going to solve for me?
Yeah. So KAITO is the Kubernetes AI Toolchain Operator. So it's an open source project that was developed at Microsoft. And starting off with AKS right now, it is able to automate the deployment of large language models within your AKS cluster. And we're working towards expanding towards other cloud providers for Kubernetes clusters. But essentially, the gap that we noticed, and a lot of people across the cloud native community noticed, was that when it comes to infrastructure provisioning, there's a lack of awareness of what kind of infrastructure to have ready for your AI workloads, for inferencing specifically. How can you do it in a low cost, cost aware mentality, and then also make a lot of those initial processes automated and reduce down those like burdensome steps sometimes in your onboarding process. So that's also where containerization of your models come in. So what KAITO is able to do is the two moving parts of the workspace controller working together with the node provisioner controller.
Okay.
And like, if I were to sum it up in like just one tagline, and especially like when KAITO first came out, I always said that KAITO reduces your time to inference, right? Because I mean, there's additional support in KAITO today that was just released a couple weeks ago, and we'll get into that. But when KAITO first came out a couple months ago, it was really about deploying a model into your cluster and provide a inferencing endpoint so that you can immediately interact with that large language model. And so as Sachi says, it's really designed in a way so that you don't really have to care about the underlying infrastructure. I don't know if you worked in Azure Cloud or any of the other clouds. There's so many different VM SKUs, and how do you decide what to pick? And how do you understand which NVIDIA device plugin or drivers work for that machine? So that's the problem that it solved initially out the gate. So it's pretty cool.
Okay, and this might sound like a really basic question, right? But I think the community went through a similar transition when Kubernetes started. It was mostly stateless, and then we started bringing in stateful workloads. Why do you think we need to run models on Kubernetes? Like, why can't I just use the Azure OpenAI service to interact with models and get that endpoint? Why do I need to run it on top of Kubernetes? Can you guys share a bit around that?
Yeah, I think the first thing is, when you interact with OpenAI models or even Azure OpenAI, that's almost in a model as a service type format, right? So the model is running somewhere, and you just call the inferencing endpoint, and that's just how you interact with it. That could be a problem for organizations that have really tight constraints around like data sovereignty, data privacy, and maybe even just latency in general, right? So having the model inside the cluster, as close to the workload as possible, I think is pretty cool.
No, and I agree, right? I think, and as Sachi mentioned in the first question, like it's AKS for now, but it will expand to other Kubernetes distribution. Maybe it becomes a part of Azure Arc Kubernetes service as well. So it's not just that you're running in the cloud and you have a managed service to consume, but wherever you want to run your Kubernetes cluster, KAITO or the open source project will allow you to run models almost instantaneously and have a local inference endpoint. So I like that. So where does KAITO fit in my AI pipeline, right? Is it just meant for inferencing, or over time you guys have added more features to it?
Yeah, so it started off with simplifying your time to inference. So getting all of the like your model image like containerized, working with that specific version of your model, getting that stored in the container registry and kind of pulling that in, getting your like service endpoint ready to start interacting with it. So that was the initial version. And that really simplified almost like days to weeks of discovery and figuring out what's necessary for the model that you particularly chosen and the infrastructure that's needed, down to just a few minutes. Within 10 to 20 minutes, you can get KAITO to deploy the model that you want. So now in the recent version, we've released support for fine tuning of your model. So with that, there are two parts to it, and we can go into that a little bit. But essentially, editing those certain layers of the model with new data that you want to essentially make your model a little bit smarter, more context aware, and then working with that output layer and pulling it into new inferencing jobs for whatever data you're interacting with in the future.
Okay, I definitely want to double click there, but I think I got like one keyword in your answer, right? Like you can now package models as containers. And so how do we do that? Like, is it something that Microsoft does for me and it takes open source models that I want and packages it up as container images and allows me to download it using KAITO, or how does that work?
Yeah, so Oh,
Go ahead, Sachi. No. Go for it. Go for it.
Yeah, so if you take a look at the KAITO GitHub repository, you can look at our library of presets. So there are several model families that we support today, and then within those model families, all different sizes. So the number of parameters and the individual sizes of, let's say, like Falcon, you can have 7 billion parameters versus the 40 billion parameter version. And our engineering team maintains those container images for each of those models. So essentially, within the custom resource definition of each of those model presets, we would provide the minimum infrastructure size that you need to essentially get your service up and running. So that is where the cost-effective approach comes in. And then it's also defined right there for you in that file.
Yeah, and that model, like Sachi mentioned, like the KAITO engineering team, they've done all the hard work in preparing the Docker file, understanding how to package that container, and we even host a lot of it's license dependent, but we host a few open source models on the Microsoft Container Registry (MCR). If you've used that before, but if you've never packaged a container, there is a little bit of an exercise in the GitHub repo for you. So if you want to package, let's say like a Llama 2 or Llama 2 chat model, due to licensing constraints, we're not able to host that on MCR. So you as a consumer get the fun part of downloading the model weights and building the container and pushing it to registry. So if you want to actually see what that looks like, take a look at the instructions in the repo.
Okay, that's super helpful, Paul, because that was my next question. Can I just take any model that's available on a repository like Hugging Face and package it up as a container image? So I'm hoping that the answer is yes, based on your previous statement.
Yeah, we have an entire recommended onboarding process for whatever custom model that you're working with. And the models that we support today or for the most part, are from Hugging Face. So they have that actual like open source license, which can also differentiate across different models that you find out there on the internet. But the advantage there is that Hugging Face also provides different libraries for fine tuning the model, for example, and like interacting with it, so forth.
Gotcha. Okay, so like when I'm publishing models or these container images that are basically models on my own, am I pushing it to my private registry or I am pushing it to MCR? That's available.
No. You would be pushing it to, like, let's say like an Azure Container Registry or whatever private registry you have. Yeah.
Okay. That's awesome. So let's talk about how KAITO works, right? Like, I have an AKS cluster today. How do I get started with it? What's the step? What's step one?
There's actually two pathways you could take.
Okay.
Let's talk about the easy path first, right?
Yeah.
So KAITO is actually available as an add-on for AKS, right?
Okay.
So it's a managed component. You just say, I forgot what the flag was in CLI. It might be like enable, like, or AI Toolchain Operator. Yeah.
Perfect.
Some flag in there. You could just say AZ AKS create and then just pass in that flag, AI Toolchain Operator, and boom, KAITO is in your cluster. It may not be the latest and greatest KAITO, but it is a version of KAITO. So that's the easy path. The more, I wouldn't say it's difficult, because to me it's pretty simple. But to get started, you would just provision your AKS cluster. And inside of the KAITO repo, there's instructions on how to provision. You need two things. It's called a GPU provisioner, which is in charge of sourcing the GPU VM for you, installing the device plugins, the drivers, and connecting it with your Kubernetes cluster. So that's one operator. And then you would have to install the next operator, which is the workspace operator. And that's in charge of managing the CRDs and reconciling that and making sure that your workspace can be scheduled on a node or a GPU node. Yeah.
Gotcha.
So
I'm assuming both of these are just simple one-line commands that I copy paste on my AKS cluster.
Install. Yeah.
Okay. Perfect.
Yeah.
So I have the operators and the CRDs installed. How do I get it to a point where I have an instance of Llama 2 running or an instance of a different model that's supported in KAITO running on my cluster?
Yeah, so like Llama 2, like I mentioned, it is a little bit more involved. You do have to package that container yourself and host it in your own private container registry. But from a user perspective, it's literally, and I took account of this, it's literally 12 lines of YAML to deploy a workspace, right? So, and I really like the way they design the API for the workspace. It makes it super simple, especially if you're using the presets, right? Because the presets, they've been vetted by the team. They know what VM SKU to use. They know, where to pull that model. And so literally you can just take an example manifest, which is in the GitHub repo as well, and literally just do a kubectl apply and apply that workspace. And so the VM SKU is in there, the model's in there, and it's actually pointing to the MCR at that point. Yeah. If you were to deploy, like, let's say a model from your own ACR or Azure Container Registry, you would have to deploy a secret into your cluster and then reference that secret so that it can pull the image.
Okay. Yeah. All of that sounds standard enough. Like there's nothing special because I'm using an AI LLM model on my AKS cluster. When you apply that configuration, does it check what nodes I have, or regardless of whether I have GPU nodes existing in my cluster, it deploys new worker nodes for me?
Yeah. So about that, cool thing is that it uses the Carpenter API. And so if you're familiar with the Carpenter project, it's all about provisioning the right resource or the right node at the right time. And so with these presets, they have some details around which node to provision. And so remember that GPU operator that I talked about, the workspace operator will actually deploy a machine manifest into your cluster. And then that GPU provisioner will see that and say, oh, okay, I need to go get a NC V3 machine and go provision that, right? So the workspace will tell the GPU provisioner what to go provision, and then the GPU provisioner will go do that. So,
and the beauty in this CRD is that it's customizable. We have some opinionated recommendations, but you can go in and see that recommended GPU VM size. Let's say it's like NC6 series GPU VM. And if you want to replace it with what you have the quota for in your subscription, something that's the same size or larger, we'll do some pre-flight validations there once you apply the CRD, just to make sure that your model can run on that infrastructure.
Gotcha. And what happens if, like, I apply that configuration and for some reason in that region there isn't enough instances available of that GPU type? I know we're not talking about H100s here, but still, what happens? Like, how do I fix that issue?
That, to me, the quota thing is probably the hardest thing about KAITO. Creating the manifest and applying it to the cluster is super easy. But for a lot of folks that never deployed a GPU VM in their Azure subscription before, chances are you probably don't have quota for it out the gate, because we don't just give everybody quota, right? You have to go and ask for it. And so that's exactly what you would need to do at that point. You'll see when you check the status conditions on the workspace, you do a describe workspace, you'll see some flags there, and it'll tell you whether or not that resource is ready. And if you wait, normally it takes about like 15-ish, maybe even quicker, to provision everything end to end. But if you start to see that the resource ready status condition is set to false, that's when you kind of have a clue that it had some trouble provisioning that resource. And then at that point, you can go take a look at the GPU provisioner logs, and you may see in there that you didn't have quota in that particular region. Yeah. And so at that point, it's just a simple support request in the Azure portal. Oftentimes, they've gotten pretty good. So oftentimes the quota requests go through an automated process, and you get approved fairly quickly. So,
gotcha. And I'm assuming, since you are using Carpenter under the covers, if I have an application that's scaling and it's sending more requests to the LLM model itself, it sees that need for additional resources and adds more GPU nodes. Is that a good assumption? Like, how does scaling work?
Yeah, just a note on that. I think, and Sachi can correct me if I'm wrong, but it uses the Carpenter APIs at this point. And I know that the team is working to eventually flip over to Carpenter or AKS's node auto provision, which is like the
Yeah.
Azure implementation of it. So,
Okay.
Yeah. So right now there isn't auto scaling implemented, but definitely something that we're working towards in the roadmap.
Gotcha. And the best part of this being an open source project is the roadmap is also on the GitHub repository. Like if
Yes.
people want a specific feature and request, I'm sure they can go and vote for that feature, I guess.
Yeah.
Oh, yeah.
Exactly.
Okay.
Absolutely.
Well, if I want to delete the cluster, I'm just going through all the CRUD operations. If I delete the custom resource, that means my nodes go away. I'm not paying for that GPU resource anymore.
Yeah, that's
Okay.
right. As soon as you delete the workspace, because remember the workspace is the custom resource you're dealing with, then the node goes away too.
Okay. So now that's all on the inferencing side. Let's talk about fine tuning, because that's something. So inferencing is easy to get my head around it. Fine tuning, right? That's obviously the next level. Like, how do I make sure an open source model is aware of the context, or has the knowledge of my database or data sets that I might have? How does KAITO enable that workflow, Sachi?
Yeah. So I can give a little bit of background on different approaches to fine tuning, and then the parameter efficient fine tuning that our engineers then chose to integrate into KAITO.
Okay.
So with fine tuning, you can essentially change all of the weights within a given model, or you can choose to edit certain weights within your model. I'm just saying it from very high level terminology, just for our average Kubernetes user. But yeah, so when you choose parameter efficient fine tuning, you can have more efficiency with the resources. You can use less of them and also save costs. So the versions of fine tuning that we support with KAITO are LoRa, so low rank adaptation, and then quantized low rank adaptation. So essentially, with fine tuning support within KAITO, there are the two processes that I mentioned earlier. And KAITO integrates containerization throughout those processes. So essentially, you have your input new data set, and you can either pull it in with how we restore it as blob storage or within a container image. And that you can format in a certain way. We give the instructions for what you're looking to achieve with that data set. And then you can choose LoRa, QLoRa, and essentially within your fine-tuning workspace, the output of that is an adapter layer that is stored as a container image temporarily. So within that adapter layer, you have these rank decomposition matrices. Essentially, they are representing changes in certain parts of your model that represent the new data that you ultimately want to be tuning the model with. So those layers, you can create many of them with different types of new data, and those will store as separate container images. And in your new inferencing job, you can pull in what those called adapters. You can pull in one or more of them into a new inferencing job and essentially be working with your smarter tuned model.
Okay. And you said I can provide it my custom data sets either using a blob storage endpoint or a container image. Does it have to be is it just a collection of files in a bucket, or can I have a relational database or a non-relational database and use that data set to fine tune my model as well?
For the most part, what I've seen is kind of like flat files. So CSV, Parquet files, and they could be files that you have, within your, I guess, your systems. But if you see it like a data set, like out on Hugging Face, and if that data set follows the formatting guidelines based on the model that you're trying to fine tune, you can literally just point to that data set and pull that in. Yeah.
Okay. So when I'm pulling the data set from Hugging Face, does it just spin up as a container with a PVC attached, or or is it every time going outside to the Hugging Face endpoint?
So there's actually a great diagram in the fine-tuning GitHub repo. Basically what happens is when your fine-tuning workspace gets deployed, it's basically a pod with multiple containers in there. And one of them is an init container. So that init container will go out, download the data set from Hugging Face, and then at that point it can work with the,
So everything is running locally on my AKS cluster. I'm not going outside. Okay, perfect.
Oh, you are to pull it down that one time.
Okay. And then when I have that adapter version of that model ready, am I just running it locally, or do I also get the option to push it to my private registry as a new version of the model?
The latter, you have that option. Actually, yeah, you're going to have to put it somewhere.
Yeah.
Whether I mean, if you want to put it in a public registry, you could. But most often we'll see customers, push that into their own Azure Container Registry or wherever.
Okay. So like all of this is it's great, right? But I want to look
Mhm.
at the alternative. Like if I was not doing it through KAITO and Kubernetes, how
Mhm.
difficult is it? Like how much complexity that we are reducing using something like a KAITO and Kubernetes?
Let me put it like this: I'm not a AI or ML expert,
Me too. Yeah.
Even if you're an
but
engineer, you need
yeah,
Kubernetes.
but just by using these tools, that's done like 90% of the work for me.
Okay.
Helps me understand and actually accomplish some of these goals, right?
Okay.
And so, what are the other alternatives? I mean, I guess the other alternatives is cracking open your own Python notebook and
Yeah.
importing the Hugging Face packages and working with it that way.
Doesn't sound as
And
much fun though.
I mean, to some is
Yeah.
probably yeah.
Yeah, no, I think people who can do that, crack open notebooks and write like or and author those are getting paid a lot more than I'm assuming
Oh
at
yeah.
least I am.
Yeah, right. Yeah. Yeah, we're just Kubernetes people.
Yes. Okay,
All
perfect.
of that
So
is really important. Oh, sorry. One other point.
yeah.
Mhm.
All of that really plays into version control. You don't
Mhm.
want to be maintaining these large model files for all different versions of your model. You kind of want
Mm.
to just maintain what is going to change along the way. Whatever new data you have coming in, whether it's your intelligent app or whatever service that you're running,
Mhm.
you can kind of just store those temporarily change layers of your model and then pull them in as needed. You don't always need to be maintaining 150 gigabyte like model sizes and downloading them every single time.
Okay, that is helpful. I think one question that led me to was Kato helps me package up models as containers. But now I have a fine tuned model, which is now a container image, but I can only run it on AKS. Is there a way to take that fine tuned model and run it somewhere else? Like, can I just have the model file available outside that container image, or it's always going to be in container if I have fine tuned through Kato?
I think it's the latter because part of the fine tuning
Yeah.
job, once the fine tuning is complete, its
Hmm.
job is to package it into a container and send it
Okay.
on its way. Yeah, so it will be. That's a good call out though. But yeah, as of right now, from what I'm aware, it packages it.
Okay, gotcha. And I think one thing that you guys mentioned at the beginning, right, that each of these models, even outside the time that it takes GPU worker nodes to be provisioned, just pulling down the container image with some of these larger models might take time. Like, are there any efficiencies around caching layers if I'm downloading the same model over and over again? How does that work? Like, are there any efficient ways of downloading these models, or every time it's a complete new pull?
Um, it's going to be a new pool once the node comes up to actually host
Hmm.
the model.
Okay.
From what I'm aware of, I don't think there's any other efficiencies that we can take advantage of. Like I know we have a feature in Azure Container Registry called artifact streaming. I don't think
Hmm.
that will help very much in this particular scenario. I was actually talking to Ishan, one of the engineers on this, about it, and
Hmm.
what he, because I asked him the same thing too. I was like, can we
Yeah.
take advantage of streaming to like download it faster? He's like, well, because it's a model, you're probably gonna want everything in the model for it to, for it to
Okay.
behave the way you intended it to. So, but I think it's something that they were going to look into, or if they may already be looking into it. But yeah, I
Gotcha.
don't think there's anything other than you just have to go pull that however many gig file that is or container image that is.
Okay, gotcha. And like Kato, I think I first learned about it last year at maybe the KubeCon event.
Mhm.
It has been a while, right? Like at least 6 to 8 months. Uh, are there any customers that are using it that are part of the community that are trying to use it and then also contributing back, or this is mostly a Microsoft-led project?
Yeah, so we've presented it in several different like customer meetings and also at KubeCon this
Mhm.
past year. And we've seen great feedback. I think people are definitely testing it out and seeing how it fits into their AI pipelines. And we've had many feature requests flow in. So lots of things adding into our roadmap. And we're excited to see people start contributing, especially once it becomes compatible with other managed distributions of Kubernetes.
Okay,
Yeah,
that's awesome.
yeah. I think as of right now, like probably the most community feedback that's happening is requests for more presets, right?
Mhm.
Um, I mean, if you get a kick out of doing that sort of work and trying to like align the stars, appropriately and try to figure out what VMs, it's always better just to have folks on the engineering team,
Yeah.
put together these presets. So, a great example of that is the new edition of the Phi 3 model,
Hmm.
which the turnaround was pretty quick ever since the model got released. So, yeah, I think that would be something that we encourage everybody in the community to do. If you have a model, or if you know of a model that you think would really benefit, as being part of this project, submit that issue. Um, you know,
Okay.
yeah. Or I think it's a pull request to go request it. I can't remember, but yeah, there's a process.
No, I think having that preset definitely helps, right? Because I don't want to figure out or like which NVIDIA instance to use for which size of
Hmm.
model, how much memory do I have available. I think somebody should do it for me. I'm here because I want a managed Kubernetes experience. Please don't ask me more questions. Just deploy it for me. So
Yeah.
I like that. So Sachi, like you as the product manager, right? This is definitely an interesting space. What's next? Like, where do you see the community is leaning towards? Are they asking for more models to be supported, more Kubernetes features to be supported? Like, what's next for KAITO?
Yeah, great question.
Yeah.
We're actually in the progress of applying for a CNCF sandbox, so
Okay.
making it official within the cloud native community. Excited for that process to kick off and really start getting more contributions from people in the community. Within the roadmap itself, we're working on the design for RAG. So that is an alternative to fine tuning. And it really
Hmm.
just depends on your scenario, whether you want to fine tune and actually change the base model that you're working with, or just make it better at retrieving information for the specific context, the data that you want. So that design for RAG will also involve integrating it with some kind of orchestration framework. So our engineers are definitely working on that currently. And yeah, so those are some of the bigger things that are a part of our roadmap. And then, as I mentioned before, extending to other cloud providers.
Gotcha. I think RAG is definitely interesting, right? Because instead of fine tuning a new model every time with my custom data set, I can just have it ready, and the data set is always up to date. I can just point the whatever a newer version of my model and have it not hallucinate and give me the right answer. So
Yeah.
when you're looking at RAG deployments, right, are there any specific vector databases that you're working on? Will those be part of the KAITO project itself, or that you leave that up to the user?
Yeah, I think when we think about the scope of KAITO, it's essentially in the name itself, it's tool chain. So it's
Mhm.
part of your entire AI pipeline. And when you look at some other vector databases that are open source project, I think MinIO is one of those options there as a cloud native option. So we wouldn't really want to create an entire like platform that encompasses those as well, but essentially fitting in KAITO to work alongside those existing like vector database options, for example.
Okay, interesting. I didn't know MinIO was working on a vector database. I need to look that up. Sorry. Okay,
I
that's
might be
awesome.
wrong. I think that's one example that I've heard of.
Gotcha. Okay. So, like, I personally, I've looked at like reactor videos, like Microsoft reactor videos on YouTube. I think you guys have done a lot of live streams. Hopefully, this podcast helps. But how can users get started, learn more about KAITO, and like get their hands on this?
Yeah. So you're right. We did do a live stream. It seems like eons ago now. But Ishan and I, we did a live stream on the Microsoft Reactor YouTube channel. You can find the recording over there. Or you can also find that recording on the AKS community channel on YouTube as well.
Okay.
And Bhavin, I think you were a guest on that show at one
I
point.
was last year.
Yeah. So there's a playlist for Learn Live on the AKS community YouTube channel. And the recording of that live session is there. Inside of the video description, there's a link to the actual hands-on lab as well. So yeah, that's what we did. So if you have an Azure subscription and you have GPU quota and you just want to try it out real quick, give it a try. It's not going to break the bank just by keeping your workspace up for, let's say, an hour. Just don't forget to delete your workspace when you're done testing it.
No, hands-on labs are always important, right? Because it gives you that controlled environment. Even if it's in your own Azure account, it just gives you the exact steps to follow. And I don't know, it makes it really easy to get started with something. So I need to find that link and go through it myself.
Yeah.
Anything
and I'll send
else
you some of these links so you can share it in your show notes.
That's awesome. No, perfect. That saves me at least 15 minutes where I have to Google for all of these things. So thank you, Paul. I appreciate that.
Yeah, no worries.
Anything else that you guys think I didn't ask and we should make it part of this episode, or we are ready to close this up?
Yeah, I think or another like resource that could be helpful is the AKS documentation as well. So for the managed add-on of KAITO, we built out some more conceptual docs to better understand fine-tuning, why it might be necessary and helpful, as well as small language models like the Phi-3 family and large language models, and when you would want to use those.
Ooh. I like that. Like, I think I'll go and read up. I think my fine-tuning skills are not as good as I want it to be. So that's a useful resource. Thank you, Sachi.
Yeah.
Perfect. Okay. So I think that brings us to the end, right? Thank you so much for being on this. This was definitely a great learning experience. I did do some research, but learned so many things during the actual recording. So I really appreciate both of you joining the podcast.
Awesome. Thank you for having us.
Yeah. Thanks for having us.
Okay. That was a fun episode. I learned so many new things. Like, I went in with some background research around KAITO and how it does help users with running models locally on their AKS clusters. So it's closer to the application, which needs access to an LLM model instead of using a managed service. So all of that is good. But learning about how they have enabled not just models that are provided by Microsoft in that container image, but now how they have a path where people can basically take an open source models and package it up as a container image on their own and then deploy it on any AKS cluster from their private container registry. That's obviously like a huge deal. And then the second fact around like, in addition to inferencing and maybe building those retrieval augmented generation or RAG architectures to enhance your inferencing workflows, now you can actually use the KAITO project to also do fine-tuning, right? So again, fine-tuning, I know the theory of it, but I haven't done it personally, or I haven't interacted or read up on it much. So that's something that's new and something that personally I need to go and look into, and how I can take an open source models and customize it with my own data set. And I'm glad that something in the Kubernetes ecosystem is making it easier for me to do that. So those are a couple of my key takeaways. I think it's an interesting project. I'm just waiting for them to expand it to other Kubernetes distributions, so it gets like more people in the community can use it instead of just customers for Microsoft Azure. With that, I think I just want to reiterate the fact that 3 years, it's been a great journey. Thank you so much for being a listener. I will again ask everybody to share this podcast with their friends if you find value in this. Even if you don't, maybe you should share the podcast regardless. But that brings us to the end of this episode. I'm Bhavin, and thank you for listening to another episode of the Kubernetes Bytes podcast.
Thank you for listening to the Kubernetes Bytes podcast.